This is an introductory presentation that briefly points to some of the fundamental flaws in the current water management frameworks. There are two objectives. 1. To alert the practitioners, companies, experts, and policymakers as to the risks of managing waters by relying on these flaws. To motivate the audience to pay closer attention to sufficiency in sequity theory with reasonable decision-making processes. This presentation focuses on 3 flaws in the management of water use systems. 1. It explains the differences between adaptation and mitigation of water problems and why they are misunderstood, making almost all the water management frameworks to promote mitigation and not adaptation. 2. It presents confusions in some of the water terminologies and 3. It explains problems with 2 famous water indicators. The first flaw is about adaptation and mitigation. Let us define them. Mitigation refers to the measures taken to reduce the underlying causes of a problem, such as water scarcity. Examples of such causes are food production and other economic activities, climate change, and population. Considering sustainable development and using C as the symbol for decision variables of society, economy, and environment, mitigation gives water policies as a function of C, which is generically called G. Adaptation, on the other hand, refers to the measures taken to manage the limited availability of appropriate water. This means that any human activity is a function of water, generically called H. Such a management must promote, as its priority, sustainable development of the scarce water itself in space-time. The almost total domination of mitigation over adaptation is because the ministries, experts, and industries linked to energy, food, land, ecosystem, etc., have much more power and money. This, of course, makes sense because historically water was not a priority, and water problems such as scarcity and pollution rarely existed in a meaningful way. Now the situation is different. Major water problems due to strong drivers are appearing all over the world, which makes it urgent to pay more attention to adaptation as defined here. There is, of course, some attempts to include adaptation into mitigation frameworks, such as the Integrated Water Resources Management, but it is structurally very difficult and produces flawed solutions, as can be seen around us. The second flaw presents confusions in some of the water terminologies. Let us examine a couple of them. It should be realized that there are 2 broad and interconnected types of water systems. One is called a water use system, and the other is a water resource system. Such an explicit distinction makes important differences, but most of the frameworks avoid it. Sometimes the same water terminology gets a different meaning between sectors, companies, and organizations. An important example is the meaning of the word consumption, which is different between irrigation and urban water practitioners and policymakers. Some utilize water consumption and water use interchangeably. At least for the water experts, they must be harmonized as follows. Water consumption is part of the water demand, or outflow or output, and is defined as the amount of outflow that cannot be reused by the same water use system during a time interval. Examples are evapotranspiration, water transfer out of a water use system, water consumed to produce meat, food, and other products. Water use, on the other hand, is the total water supply, or water inflow or water input, into a water use system. Consequently, water use must be equal to the consumptive water plus non-consumptive water. The third flaw briefly presents the problems associated with 2 of the main indicators employed for managing water use systems. All sectors, including urban and agriculture, have been employing classical efficiency for many decades. The name and the form may be different here and there, but its most popular and generic form is shown here and gives the ratio of beneficial water to total water. For example, the numerator can be beneficial water use, beneficial water consumption, and beneficial water required. The denominator can be total water applied, total water abstracted, total water allocated, and total water required. However, classical efficiency is a flawed indicator, having in mind the following issues. 1. Incompleteness of water quantities, particularly the lack of the inclusion of return flows in the equation, which also makes it inadequate for analyzing multi-objective water use systems. This means that this kind of water efficiency does not obey water balance, one of the most important laws in studying and designing water systems. 2. Partial consideration of water attributes, i.e., lack of a complete concern for applying water quality and benefits or values. For example, the numerator considers the beneficial part, but this distinction is not extended to the denominator, because efficiency is an inherently value-laden indicator, and consequently it is about differentials and not absolutes. This means that classical efficiency is a quantity indicator, with no or partial consideration for water quality. Ignoring water pollution of all the inflows and outflows of a water use system leads to wrong conclusions. For example, all things equal, if system A pollutes more than B, then B is more efficient. 3. Because of the above two issues, classical efficiency cannot reveal the inherent nonlinearity among the three pillars of a water use system, namely, water quantity, water quality, and water benefits, or the values derived from the first two pillars. This deficiency causes a lack of understanding of the trade-offs between these three pillars, and in general takes away the ability for a proper analysis of rebound effects. Another indicator employed frequently is water productivity, with its generic expression given here. Other forms are also utilized, such as its inverse. All are flawed for various reasons, including the main reasons given for classical efficiency, which are lack of comprehensiveness and consequently lack of understanding trade-offs. For more, please refer to the references given. If interested to know more details of the three flaws mentioned here, please look at these references. Thank you.